Okay, we need to look at Wireshark. Wireshark is a packet capture tool. We've talked about what packets are, and now we're going to look at packets as they traverse the network. Anyways, in Windows or Linux, it's fairly similar. You need to open up Wireshark, and then you need to find something like this, a blue line that says what interface you're going to capture on what network interface card. You click, and it starts capturing. One of your first assignments says load up a website. So here I've loaded up Woot, but I'm going to go ahead and, I'm going to go ahead and refresh that so that we can see the traffic as it comes along here. And as we look back at Wireshark, we see a bunch of traffic as it's going along, and it's getting a bunch of different images, and this is application layer stuff. We'll talk about HTTP in a later part. Anyway, I'm going to go ahead and hit stop here now. And our assignment says, let's filter by HTTP. That says, just show me the HTTP packets. So that's what we are looking at now. Our assignment asks us to answer a few questions. The size of the entire packet, and the size of the 4 layers. Well, you find the packet that you're interested in. Let's choose that one. We have several different panes. This top pane shows all the packets that we've captured. This next pane, this middle one, drills down on that packet for us so we can see what is in that packet. So in this case, or vice versa, what that packet is in, we have a hypertext transfer protocol packet, which is inside of this packet, which is inside of this packet, which is inside of an Ethernet packet, which we finally put on the wire itself. And we're going to be talking about each one of these different layers as we go through the course. But it says the size of the entire packet and the size of the 4 layers. Well, if you look down here at the bottom, you can see that this frame that contains everything is 396 bytes. The HTTP packet is 342 bytes. So the difference between 396 and 342 is what our overhead is. And so you do something like that. The total number of bytes used up in headers that are not part of the application layer. Well, that's basically what I was saying. We could look at the size of the 4 layers individually here by clicking on, say, Ethernet. That one's 14 bytes. Internet protocol, that one's 20 bytes. Transmission control protocol, that is 20 bytes. And then HTTP is 342. So between those two questions, we can get the information that we need, or between that information that we looked at, we can answer those two questions. We can look at where get IT2400 appears in the raw packet data. Well, this is our raw packet data down here on the bottom right hand side. Here, for example, is a get request that says get Ajax libs jQuery. Now, I didn't do the same site that we're asking for over here, but you should be able to scroll down, and in fact, you won't have that many get requests if you're accessing the CIT site. You'll just have 2 or 3 perhaps, but it should be relatively easy to find that. You need to find the time to live field in the IP header. Well, here's our IP, Internet Protocol. We can expand that, and if you expand that a little bit, time to live, bing, there it is. And the amount of space it takes up in the header. Well, if you click on that again, time to live, it shows us that that is actually 1 byte worth of data. And then it says, show us 5 other protocols we've observed during the trace. I don't know that I'll have it on mine, but I'll just sort here. So we see HTTP, a lot of HTTP. There's some DNS traffic. There's some TCP protocols. I'm looking in this column right here. On campus, you're going to have a lot more, but on my little home network, I don't have that much. So that, in essence, should be our assignment.